I'm Dr. Claire Fedeli. I'm joined by Professor David Botel and Dr. Liz Christie, and we're going to be discussing Peter Macs Ovarian Cancer Research Program. Welcome, Liz and David.
Hi, Claire.
Hi. David, when did you start working on ovarian cancer, and why ovarian cancer?
It was in the early 2000s. So what really kicked it off was a program grant from the United States that allowed us to create the Australian Ovarian Cancer Study, which is a study of over 3,000 women now with ovarian cancer. So that allowed us to have the resources to investigate different questions about ovarian cancer. We decided to work on it because we saw there was a gap. It's a reasonably common form of cancer deaths in women. It's the most common cause of gynecological cancer deaths, and yet it's relatively under-researched. That's improved a bit, but there's a gap.
And how have you seen the research change over the years?
Well, back when we first started, ovarian cancer was sort of thought of as a single disease that came from the ovary, and we've really appreciated over that time how it's actually multiple different diseases that share an anatomical location in the body, but really not very much else. They respond differently to chemotherapy, common treatments. They have different genetic roots, so there are certain types of ovarian cancer that are more associated with inherited forms of the disease. And we've seen the treatment really evolve. So for example, PARP inhibitors have become very important in the treatment of particular subsets of ovarian cancer patients. So what we're seeing now is the fruits of understanding the biology really translate into the clinic and how the disease is managed.
And Liz, what approach are you taking to better understand ovarian cancers?
So we're taking a really comprehensive approach, particularly looking at the genetics and the underlying features of the cancer cells and trying to understand why patients do or do not respond to common treatments like chemotherapy and PARP inhibitors.
And what have you found? What are some of your latest results?
So we've found that the cancers actually can become resistant to chemotherapies through multiple different pathways, and that's really important when we're trying to design new treatment strategies and actually make sure that we're giving patients only drugs that will actually be effective for them.
Wow. And David, how are Peter Macs' efforts in ovarian cancer research contributing to global efforts to understand this disease?
Well, to give you one example, one of the studies that we're heavily invested in is a study of patients who have exceptional survival. So this is the most common type of ovarian cancer. It's called high-grade serous cancer, and unfortunately the 5-year survival for that is around about 40%. But there's a small proportion of patients who are alive and well after 10 years, some of them without any disease recurrence during that time. So this is called the Exceptional Responders Study, and it's part of really a global initiative to identify these patients and to analyse them and try and understand how they manage to beat the odds, I guess. And so it's called MOCOG. It's again funded from the United States, and it involves us here in Australia, investigators throughout the United States and in Canada, in the United Kingdom and in parts of Europe. So because these patients are uncommon, it's very important to work globally to amass the numbers that we need to really try and pick apart these remarkable patients and their survival.
And can these types of international collaborations help to give insights to other types of cancer, or are different types of cancers completely different to each other?
Yeah, I think that's one of the things that that's been a real surprise over the last 5 or maybe 10 years, really initiated through the genomic studies that we and other laboratories around the world have been involved in. You know, maybe an analogy is useful here. We think of people as being American or Irish or Australian because of where they're located in the world. And in the same way, we think of cancers as breast cancer or kidney cancer or ovarian cancer because of where it's located in the body. But when you start talking to people, or even if you analyse their genes, you can find that people in Boston share some real similarities with people in Dublin, you know, of Irish heritage, or Melbourne and Athens, you know, of Greek heritage. And the same is true for cancers. Now as we start to investigate the genes that drive them, we find that there are unexpected similarities. So that high-grade serous cancer that I mentioned before is molecularly very closely related to an important type of breast cancer called triple negative breast cancer. And so there's been this sort of reclassification of cancer based on its molecular underpinnings, and that's helping us understand commonalities and approaches to treatment, and we're able to borrow experience from one disease across into another situation, and so make things move faster in terms of improving outcomes.
Well, thank you so much, David and Liz, for sharing your insights into how ovarian cancer research done right here at Peter Mac can have real global impacts for the way that we think about all types of cancer across the world. Thank you, David and Liz.
Thanks, Claire.